Dr. Powell. Let's take a look at how we can use simpler representatives in modular arithmetic to make computations. For instance, what if we had 27 to the 7th power, and we're looking at a simpler way of writing this in mod 11 arithmetic. Okay, so we have a quotient z mod 11z, and another way of saying this is we're looking for a simpler way to write 27 to the 7th mod 11. Okay, and the different elements in here, kind of what we've done is we've taken the integers and we've chunked them up into pieces. So we can have the piece 11z, all right, so that's like multiples of 11, or 11z plus 1, or 11z plus 2, and so forth. So 1 more than a multiple of 11, 2 more than multiple 11, and we can represent these as chunks, like 1 bar, 0 bar, 2 bar, 3 bar. So really from 0 bar all the way up to 10 bar, every single integer lives in one of these chunks. And the question is, 27 to the 7th lives in which chunk? This bar notation simply means what chunk does 27 to the 7th live in? Now all the chunks can be reduced to simpler representatives. Like this is a really big representative, but we want a smaller one, like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10. We want a small representative, and we want to know which box it fits in. So this is an integer. Which box is it going to fit in? So this bar notation, we're going to be using that as we proceed and as we go along. Okay, so in making this computation, first of all, we notice that the bar notation, so modding out by 11, splits nicely across a multiplication, also splits across addition. So a times b is the same thing as a bar times b bar. There's a nice operation induced on the chunks from the operation before we chunk, just on the integers. And the same thing happens if we were to place it with addition. So addition works, multiplication works. And in particular, because multiplication works, we also have that this power can move to the outside. So we could think of like this, 27 bar raised to the 7th power like this. And now we look at this, 27 bar. Can we reduce this and find a simpler representative for just 27? See, which box does 27 fit in? Well, 27 is 5 more than 22. 22 is a multiple of 11. That means it fits in the box 11z plus 5, which is 5 bar. So really, this is just the same thing as 5 bar to the 7th. We've already simplified this quite a bit, just right there. Next, let's take a look at this exponent, 7. We can rewrite 7 in terms of powers of 2. 2 squared plus 2 plus 1. That's actually really nice because now we can rewrite this as 5 bar, and this is 4, 5 bar to the 4th times 5 bar squared from this guy times 5 bar to the 1st from that one. All right, so let's think about what 5 bar squared is. So that's 25, because we can put 5 bar squared, we can pop the squared back inside under the bar, think of it as 25 bar, and just find our simpler representative for this. This is 3 more than a multiple of 11, so it's 3 bar. And so already we know that this guy right here is just going to be 3 bar. Okay, and this guy is 5 bar. We can even multiply those together right now. I know that's 15 bar, and 15 bar is 4 more. So 15 is 4 more than 11, so this is actually just going to be 4 bar right here. So so this right here, all right, is 4 bar. So we already know this part of the calculation. Now what about this guy? Now realize that 5 to the 4th, I mean, that's going to be the same thing as like 5 squared bar times 5 squared bar. And we already know that 5 squared bar is the same thing as 3 bar. Okay, so 3 bar times 3 bar. So like when we just have the bar over something, that means we can reduce. That's why we split it up and then we throw the bar back over. It's kind of a nice idea. So here we have 3 bar times 3 bar, which we could put the bar over everything and just say that's 9 bar, which is one of our simple guys, 0 through 9. And if we really want a smaller number, we could actually replace 9 bar with negative 2 bar because it's 2 less than a multiple of 11. It's 2 underneath 11, and negative 2 is going to be in the same chunk as 9 bar. So, okay, so we got this part right here, is 4 bar, and this guy we've just found out was negative 2 bar. All right, so negative 2 bar times 4 bar. That would be negative 8 bar. So we're really well on our way. We got negative 8 bar, and that's pretty simple. In fact, we could think, okay, what's 8 less than 11? That's just 3 bar. Wow. Okay, so what does this calculation say? We have discovered that right here, we have that 27 to the 7th power, whatever it is 3 more than a multiple of 11. And we did that without actually computing what that huge, terrible number was. We just simply used the ideas of modular arithmetic and how things split over bars and how we can reduce representatives as we move along. Let's look at one more example of this. Okay, so if we move along to 2 to the 101 power, and let's consider this mod 5. Okay, so all the bars are going to be representing shifts of 5z, and we're going to be looking in the quotient z mod 5z and the chunks that live in there. 0 bar, 1 bar, 2 bar, 3 bar, or 4 bar. So really this is multiple choice. So if I did 2 to the chunk that 2 to the 101 lives in, it's either this chunk, this chunk, this chunk right here, right? So the chunk that 201 lives in is either 0 bar, 1 bar, 2 bar, 3 bar, or 4 bar. Which one is it? So to make this computation, we're going to actually notice a pattern here as we move along. Okay, so for starters, let's just kind of compute some of these things. So if we have 2 squared, all right, what's that? Okay, so that's obviously that's 4 bar. Okay, and realize that 4 bar is the same thing as negative 1 bar. It's 1 less than a multiple of 5. So that makes this, well, that's really nice if you see a negative 1, because then you think, okay, 2 to the 4th bar, what's that? That's going to be the same thing as 2 squared bar times 2 squared bar, and that's negative 1 bar times negative 1 bar. You can throw this bar over both of them. Oh my goodness, look at that. Negative 1 times negative 1, that's 1 bar. Whew. So every 4 in the exponent, we actually get to a 1 bar. That kind of tells you that the exponents are really behaving like in mod 4 in this particular case. So every 4, it's going to be like nothing happened. So, because we'll begin multiplying by 1 bar. So really, think about this, 2 to the 100th power. So that's kind of what this will be. This is the same thing as this. Notice that 100 is a multiple of 4. Oh, wow. So this is going to be equal to 1 bar. Oh my goodness. So the whole thing is equal to 2 bar. And we just figured out that by multiple choice, which one was it? 2 bar 1. And we got it. Thanks for watching.